Let's do another ginormous marathon section of reactions. This is going to be the preparation and the reactions of our next carboxylic acid derivative, the acid anhydride. And so let's just remind ourselves what this functional group looks like. This is the second most reactive carboxylic acid derivative. So it's going to have, warning, it's going to have a lot of reactions as well. We're going to start by looking at how to make it. And there are a lot of different ways. There are quite a few different ways to make acid anhydrides. The method that you have in your textbook that we're going to stick with is to take the acid chloride and react it with a deprotonated carboxylic acid. If you want to look at the mechanism for this reaction, it is, I'm going to put a little R prime on there. The mechanism for this reaction is around page 1011. It's on page 1011 in my textbook. And you can kind of visualize what's going on with this reaction, but I'm going to highlight for you so you can see what's happening. You can imagine what that mechanism looks like. So again, there's a lot of different ways to make acid chlorides, but this is the method that your book uses, so that's what we're going to go with. Now we're going to get into the reactions. And these are going to look really familiar. So starting with hydrolysis, let's take our acid anhydride. We are going to be reacting it with water. We do not need to use pyridine in this reaction. The reason that we needed to use that in the acid chloride reaction was that the acid chloride reaction would have the potential of producing HCl, which is a strong acid and reactive. So the pyridine's job in that reaction was to suck up HCl. But as you can see, acid anhydride doesn't have any chlorine in it, so we don't have that possibility. So this is just with water. And this makes a carboxylic acid. And you know what I'm going to do? I'm going to rewrite this H2O. I'm going to write it differently. Write it like this so you can see the OH and where it goes. So this is producing like a whole chunk of leaving group that is pretty significant. There's a big old leaving group coming off of this thing. And actually, a lot of times what we end up seeing is a couple carboxylic acids, 2 carboxylic acids being made. So this will raise questions with students like, what if these 2 R groups are different? What's the actual product of this reaction? Let me draw an example of what I mean. So what if you had this as your acid chloride and you were asked to do hydrolysis? Would the product of this reaction be the carboxylic acid made from the left half of the molecule, the way that I drew it, or would it be made from the right half of the molecule? Which one? And the answer is both. When this reaction takes place, when the nucleophile attacks, the nucleophile is happy to attack either carbonyl carbon. So that means you're going to get either one of these products. And the problems that you're encountering, I haven't looked at everything in sapling yet, but you're going to be dealing with symmetrical acid anhydrides. So you're not going to be looking at ones that have 2 different R groups, and therefore you won't be looking at examples where there's a potential for 2 different products of the reaction. So that'll keep it simple for you. The next thing that we see happening is aminolysis. Oh, I skipped alcoholysis. That's okay. We'll come back to alcoholysis. Aminolysis. Again, we're just going to really limit our examples to symmetrical acid anhydrides to keep things easy for you. we are going to need an excess of the amine for this reaction, and we are going to produce an amide. Just like with the acid chloride, you can use NH2R, or you can use NHR2. Either one of those. There just has to be at least one hydrogen on the nitrogen. Now let's do alcoholysis, since I skipped that one. Alcoholysis. This will be our acid anhydride with an alcohol. This one I am going to make an R prime so that we can distinguish it from the R groups on the acid chloride. And this is also going to make an ester, just like the acid chloride does. Right there, and I'm going to highlight the parts that go on that molecule. Beautiful. It's okay if you think this is kind of boring. These reactions aren't super exciting. They're very redundant. Next up, we have reduction to an alcohol, which we also have with the acid chloride. So there's a lot of overlap here, a lot of similarity. Same reagents, we need excess lithium aluminum hydride. We're going to follow it up with either water or dilute acid, and this is going to make a primary alcohol. Be careful that you don't lose your carbonyl carbon in this reaction. Mechanism is the same as it is for an acid chloride. Just like with an acid chloride, we can do reduction to an aldehyde. If we don't want to reduce all the way to an alcohol, we can reduce and stop at the aldehyde, and guess what? It uses the exact same reducing agent, lithium, aluminum, tritert-butoxy, 3s for days, tritert-butoxyhydride, lithium, aluminum, tritert-butoxyhydride. Your textbook abbreviates that, but I don't like to abbreviate it because it makes me feel like a badass when I write it all the way out. Now, this is going to reduce to an aldehyde. And then we have reactions with Grignards. Oh, I know this is not the most exciting topic of organic chemistry. So this is also exactly the same as when we are reacting a Grignard with an acid chloride. I don't know if you can see that. I made that R prime. Followed by either water or a dilute acid, and this is going to, just like with the acid chloride, it is going to react 2 times. We're going to put 2 of the R prime groups on the carbonyl carbon of the acid chloride. Whew. And then one more, last one, reaction with the dialkyl cuprate, the lithium dialkyl cuprate. Acid anhydride. This is a single step reaction, R prime 2 CuLi. There's no follow-up. This is the reagent that we use when we want to form a ketone instead of going all the way to an alcohol. And just like in the reactions of the acid anhydrides, or excuse me, the acid halides, acid chlorides, you have in your textbook figure 2110, which is going to be on page around 1011. And you also have the review at the end of the chapter. So this is not at the very, very, very end. This is before the homework problems. It's like right at the end of section 21.15, like the next page, review of reactions, which in my book is on page 1034. And that again is going to have like that starburst, or some people call it a roadmap, of all of the different reactions of anhydrides, as well as ways to make anhydrides. Again, a really fantastic resource.